All right, let's try example number 4. So let's say I give you a Ferris wheel and I say it takes 2 minutes to go around once. All right, so example 4. All right, so example 4. Let's say I give you a Ferris wheel that takes 2 minutes to go around once. It's going clockwise and the passenger gets on at the bottom. Okay, so I'm given a Ferris wheel. With diameter 35 feet. It takes 2 minutes to go around once. Clockwise. And please write a parametric equation that models the location, let's say models the two-dimensional location of a passenger getting off, getting on, off at the bottom. Okay. It's probably terrible wording, but let's see. So you're given a Ferris wheel, a radius 35 feet. The passenger gets on at the bottom. So we're going to make that then 0, 0 on the XY axis. Okay. All right. So, well, if you're going to write an equation, you want to start with a table. It takes 2 minutes to go around. So let's break that up into a time interval from 0 to 120 seconds. Okay, so then halfway 60 seconds, quarter of the way 30 seconds. Okay. So the passenger gets on at 0, 0. So our x coordinate is 0, our y coordinate is 0. And it takes 2 minutes to go around to get back to 0, 0. That means halfway, we're at 70 feet. So up here, we're at 70 feet height, 0 feet on the XY axis. So I would put 0 and 70. And then a quarter of the way, at 30 seconds, if I'm going around clockwise, then I'm over here at negative 35, 35. And then 90 seconds in, 3/4 of the way, I'm at 35, 35. Okay, so then let's write a parametric equation for x and for y. So let's start with x. Our input is, our input is time, output is our x value. So we're going from 0 to 120. At 0, we're at the origin. At 30, we're at negative 35. At 60, we're back at the equilibrium point, then we're up at 90 to positive 35, back to equilibrium. That looks like a sinusoid. That looks like a negative sine graph. So this is some sort of negative sine function with an input of t. All right, so then let's write an equation for a sine graph. We've done this before. We start with our a value, our amplitude, and then our b value is determined by the period. So if we solve for b, we get that b is 2 pi over 120, which is pi over 60. That's our b value. And our input variable is t. This is our parametric equation for x. Okay, let's do this for y. You can try pausing this and then making this a u try. But I will, and then play again and then check my solutions. Okay, so now let's look at our equation for y given t. We have the same period, so we're probably going to have the same b value. And we have the same max and min, so we're probably going to have the same a value. So then let's see what we get. So we start at 0, go to the max, back to equilibrium, down to the minimum, back to equilibrium. We have a negative sine graph. Sorry, we have a regular sine graph. So our y of t is then some sort of sine function input t. Our amplitude is 35. That's our max. And the period, 2 pi over b. We get pi over 60. Input variable is t. Okay. So again, we wrote an equation for x. And we wrote an equation for y. Okay, and that's it for example 4.